So today's talk is about decoupled libraries for PHP. Before we get started, anyone that's been to one of my talks before knows that I like to give book recommendations at the very beginning. There's nothing that I'm going to tell you today that is more important than what these people have to say. Both of these books inform this presentation. The first one is called Patterns of Enterprise Application Architecture. Who's heard of this book? A few? Yeah, Cornett. You don't count, man. Any answers you give? So who's heard of the term model view controller, MVC? Right? Active record, maybe table data gateway, data mapper, stuff like that. All those terms come out of this book. The interesting thing about this book is when you read it, you're going to see him describing things that you're already doing. The important thing about this book is not the things that he is describing. It is that he is giving names to the things we are already doing. This book gives us a common vocabulary to talk to each other about the things that we are doing. So if you have, say, an SQL script that you run every once in a while to do a particular set of things, say over and over again, you can either give that description, or you can say we use a transaction script for this particular task. That's one of the patterns identified in this book. So patterns of enterprise application architecture. The other one is called refactoring. Who's heard of refactoring in general in the first place? So the idea in this book is that it gives you ways to improve the quality of the code base that you're working in without changing the functionality of the code base that you're working in. So when you're done doing refactoring stuff, the code is going to be easier for you to work with, but the functionality will still be the same. It'll just be easier to maintain. And again, both of these books inform this presentation. A little bit about me. My name is Paul Jones. I've been programming PHP since 1999. Before that, I was paid to be a spy. I was in Air Force intelligence for 8 years. You can make your military intelligence jokes now.
There is such a thing?
Yeah, exactly, yeah. The oxymoron of military intelligence, right? Yeah. So, but I've been programming in general since 1983. So if anyone here was born after August 1983, congratulations. I've been doing this longer than you've been alive. That's good and it's bad. I'm not quite sure how I feel about that. But in that time, I've been everything from junior developer, senior developer, VP of engineering. As far as code is concerned in the PHP world, I'm the lead on what's called the Aura project. I've done a benchmarking series measuring the overhead of different benchmarks when they get invoked. Who uses Zen framework at all? So the ZenDB and the ZenView portions, I wrote the version 1s of those. If you like them, cool. If you don't like them, I'm going to say that they got changed after I got done with them. As far as community work, I was an advisory board member for the Zend certification exam. Who here has their Zend certification? Yeah, Zend all the way, huh? I strongly recommend, just professionally speaking, that you get your Zend certification, not because it is going to make you a better programmer, but because it's going to make it easier for employers to identify that you are committed to your profession, at least committed enough to take the silly test to prove that you know the language. So that's my plug for Zen certification. Who here has heard of the PHP Framework Interoperability Group, or the PSR standards? So PSR 1, PSR 2, the coding standards, I was the guy who shepherded those through the process. PSR 4, I was the primary author with a guy named Bo Simonson. So today's talk, we're going to be talking about decoupled libraries. In order to talk about that, I'm going to have to give a little background on PHP, where it used to be and where it has gone to now. When we're done with that, we're going to talk about the principles of writing fully decoupled library packages. And by way of example, I'm going to use packages from the project that I'm working on now, the Aura project. At the very end, we're going to talk about the limits to decoupling packages, because you can only decouple so much. After a while, you've got to start gluing things together. How do we go about gluing together these decoupled things? So a little background. Who has a good George Takei voice? Nobody? Oh, come on, don't make me do it. But libraries, framework, components. Oh, my. So it used to be, way back when, the PHP 3 days, and I mean this is like pre-2000, also in PHP 4 and in the early PHP 5 days, if you used the word framework among other PHP developers, they would run you out of the room. Using a framework was not something PHP developers wanted. You heard Laura talk about this morning. You may have heard Ed Finkler talk about this a little bit too. What PHP developers wanted was individual libraries that they could glue together themselves. They didn't want to be forced into a particular way of working. So what you saw back then were individual libraries, and also things like library collections, like the Horde project, the Pair project. You saw websites dedicated to publicizing individual libraries of varying quality levels, like PHP classes and Fresh Meat. The problem with this was even among the library collections, where all the individual libraries were part of the same project with theoretically the same standards, all those individual libraries in the collection still worked kind of differently. They had different constructor signatures. They had different ways they named their methods. They had different ways or different idioms of usage. So that made it tough to combine them. If you used one library, library A and library B, you were used to using one, you had to kind of relearn everything in order to learn how to use the other one. So with that in mind, and having used these library collections myself, back in 2004, I started a project called the Solar Project, which was originally a collection of libraries. As a library collection, I think it was the first of the PHP 5e strict libraries, to combat this specific problem. That is, we wanted to make everything work the same. If you figured out how to use one Solar library, you would know how to use all of the other Solar libraries, because they all looked and felt the same way. So I said we didn't like the word framework. That was until Ruby on Rails came out. Who remembers the one thing that drove Ruby on Rails to its great popularity? A 15-minute video, how to build a blog in 15 minutes. This looked fantastic, and Rails called itself a framework. So all of a sudden in the PHP world, framework was no longer a dirty word. Everyone wanted to build a framework, and you saw this huge explosion, 2004, 2005, and a little bit thereafter, of people writing frameworks in PHP because now it was socially acceptable. Agave, Mojave, Cake, Symfony, PHP on Tracks, which is direct, the name's clearly a ripoff. Zen Framework, people do the weirdest things with names, man. Zen Framework, tons of others. What was interesting about this, in retrospect, is that these frameworks clearly tapped into developer needs, because while there's still a bunch of developers who didn't like frameworks at all, there were a lot of developers out there who just wanted to get stuff done. They didn't necessarily want to be the greatest program in the world. They just wanted to write their application without having to know too much. And in addition to that, in addition to those technical needs, and again, this is in retrospect, it really tapped into a lot of non-technical needs as well. Being able to say you're part of a framework ecology, you get to be part of a tribe. You get to be part of a unified community that all have the same ideas about things. These are emotional, if I dare say so, religious needs that we have. So it wasn't enough, so previous to the frameworks, it was enough to say, I'm a PHP developer and you Java guys are dumb. Everything you're doing, we stand against that, we're PHP guys. But then we got these subsects in PHP where if I'm a Cake guy, you Zen Framework guys are dumb, right? If I'm a Zen guy, you Symfony guys are dumb. If I'm a Symfony guy, you're a lazy DO. You got to say it in French if it's Symfony. And in addition to that, it was no longer enough to write a PHP library. If you wrote an authentication library, you didn't write for PHP, you wrote a Cake authentication library, and you got the adoration of your peers within the Cake community, and all that feels really good. So again, frameworks are not necessarily just about technical stuff. There's also a lot of emotional needs that get fulfilled there. Talking is thirsty work. So after a few years, PHP 5.3 came out, and all of these first rounds of frameworks started doing their second round of development. The Cake guys split off to do Lithium. Symfony started Symfony 2, Zen Framework started Zen Framework 2, others started their second versions as well. But in addition to this, with 5.3 and the introduction of closures, we started seeing micro frameworks like Slim and Glue and Lemonade. Who here is a micro framework kind of person? Only one or two. Yeah, they definitely have their uses. The difference between the full stack frameworks and the micro frameworks is that the micro frameworks still bind everything together for you, but it's a very limited subset of stuff. Whereas Zen Framework and Symfony all come with a form system, a cache system, a logging system. The micro frameworks only come with something to look at the web context, request and response objects, router and dispatcher. That's pretty much it. Maybe there's some middleware attached, but that's about it. Because these guys, we're looking at these guys and saying, we don't want all that heavy stuff. We just need a small subset of things. We want to be able to tack on the other libraries that we want. We can kind of start seeing the pendulum swinging back now. We had started with libraries, we'd gone to frameworks, and they're starting to swing a little bit back. Not really getting rid of frameworks, but sort of wanting to mix them in. The reason for that is all of these first round of monolithic frameworks, well, they're delivered as a monolithic whole. You download the whole framework if you want it. You use the whole thing. If all you want to do is use part of the framework, say you just want the database connection stuff out of Zend, you can't just download the database part. You've got to download the whole thing, and then if you want to, you can use just the database part, kind of. The problem is that the database component depends on other parts of the framework, so you end up having to set up other things in the framework that you don't care about just to use the database component. So with that in mind, when these guys started their second round, because they all heard these complaints, when they started their second round of development, they said, OK, we're going to use a component-oriented system. We're going to make it so that you can use just the database part or use just the view part. Now, I say they went to components. I say they went kind of components. Because when I think of a component, I think of something that I download. I get just that thing and nothing else. That's not quite the case with Symfony 2 and Zen Framework 2, at least not consistently. So in order to talk about why I say they're only kind of decoupled and not fully decoupled, we have to understand what decoupling means. And I'm not going to read these to you. You can go to these links. You can read these papers if you feel like it. This one here is specifically about class-level decoupling. We're not going to pay attention to that so much, but the concepts are important. The basic idea behind decoupling is we want to set up modules in our code that are independent, completely independent of any other modules in the code. This can even go so far as to being independent from the use cases under which we're going to use that code. So again, decoupling means to make the features of the formal system independent, controls that separate code modules from particular use cases. We're going to show examples of both of these. These lead us to the principles I'm going to talk about later. Specifically, we're talking about framework-level decoupling and package-level decoupling, not class-level decoupling. So we're going to say, when we talk about decoupling in this talk, we want our packages to be independent of any other packages and independent of any combination of them. Does everyone get the thrust of what we're going for here? So let's go back to Zen Framework and Symfony. Let's say you want to download the Zen input filter. Again, when I think of getting an input filter component, I think I'm getting just that. But if you use Composer to install the Zen input filter, you get these 5 packages. And the question is not, is it reasonable for these packages to be coupled in with it? The question is, does this mean Zen input filter is a decoupled independent component? The answer to that is no. You have to download all of these other things in order for the input filter to work. Now, if that's what you want, that's cool. But that's not the kind of thing I'm looking for, and it's certainly not what I think of when I think of a standalone component. Now, the Symfony guys do a lot better on this. But I want you to pay attention. This is directly from their marketing page on Symfony components. They can be used standalone. They have no mandatory dependencies. Turns out that's not entirely true. Of the 21, 22-odd components they list on that page, and I did the research on this, 11 of those packages, this is completely true. 11 of those packages are totally independent. But 4 of them have lots of dependencies, so they're not standalone. They're not living up to their marketing phrase here. And 6 of them, it's kind of debatable. And those are the parts that I want to talk about. How do you tell, just by looking at a code base, by looking at a package, if it has dependencies or not? How can you tell if it's decoupled? Well, the easiest way is to look at the composer.json file. And the guy previous was talking about JSON, right? He was talking about Composer. Is that correct? So you guys, those of you who attended that talk know this. You can look at the require line. And if there's a require line for any other package there, you know it's not fully decoupled. You know it has dependencies and other stuff. It gets kind of interesting when we talk about required dev. Did he talk about the required dev line? So for those of you who didn't attend, the required dev line is these are the things you need in order to work on developing this package, not necessarily the things you need in order to use the package. So if you see a required dev line for other packages, it's not as easy. That required dev line might be for additional tools, or it might be for optional functionality. So you have to go in and actually look at the code to see if it's fully decoupled or not. The easiest way to determine by looking at the code if it's decoupled or not, and I don't have the example of the second one, the first one is to look for the use statements. Now, the Symfony component router has this class annotation loader in it. And again, Symfony says routing is completely separated. It's totally standalone. That's not entirely true. If you want to use this part of the routing system, you have to have a package from a completely different project. You have to have the doctrine annotation system. And then you have to have the Symfony component configuration component in order to use this. So we look at this. The other way is to look at the classes and see if there are any new statements in it, any new keywords that try to drag in classes from other packages. So when you talk to the Symfony guys about this, anyone here use Symfony? So you know, and you've heard this argument, and this is a fair argument. They say this is optional behavior. The package is still decoupled, and if you don't use this, if you don't use the annotation loader, then you don't need to load in the other package, right? That argument doesn't really hold water with me. I understand where they're coming from, but it sounds to me like it's the same thing we said about the frameworks to beginning. We don't have to use everything, right? You can just download it all and just use the parts you want. It's sort of the flip side of the same coin. So for me, this is not fully decoupled. So again, When we're talking about decoupled packages, the Symfony stuff might be decoupled from the framework, but the packages are not decoupled from each other. And again, who went to see Ed Finkler's presentation last hour? Ed Finkler talks about exactly this. When he downloads this stuff, he wants to see just the one thing, not a bunch of other dependencies. That's what drove him to write the micro PHP manifesto. So now that we've talked about what a fully decoupled package ought to be like, when we're writing our own packages, what are the principles we need to keep in mind when we're doing that kind of thing, if that's the kind of thing that we're interested in? I said earlier, I wrote back in 2004, the Solar project ended up becoming the Solar framework. At the time, and we're again going back in time a little bit, October 2010, the project was 5 years old, it was 1.1, it was mature, it was stable. But a lot of people had asked us, can we use just the database component? Of course, the answer is no, it's monolithic, you have to download the whole thing. So we decided for the version 2 of Solar, first of all, we were going to rename it as Aura because everyone was getting Solar, S-O-L-A-R, confuses S-O-L-R, the Lucene search system. Yeah. So we renamed it Aura. The name is a pun. I'll tell you about that later. We were going to do it specifically as independent decoupled library packages. And specifically according to the principles that I talked about earlier, that is, no package should depend on any other package. It should be separate from the framework, and it should also be separate from all the other packages. So we started version 1 on October 2010. The idea was to extract all the what we thought were the important components according to the PSR0 autoloadings, or what would become known as the PSR0 autoloading standard. We completed that portion of the project last year, July or August, I don't recall. In doing that work, we realized that some of the packages that we had extracted, some of those packages were actually doing a little bit too much. It would be possible to separate those single packages into their own independent packages that also wouldn't depend on each other. So we started V2 September of last year, just made some beta releases over the 1st through the 15th of January. And instead of using PSR0, we're using PSR4, which is a new autoloading standard, slightly shallower directory structures. Who here, do you guys know about PSR0, PSR4? One guy. If you don't know about this stuff, I really strongly suggest going to php-fig.org. These are really good, these are good standards. They're recommendations, but they're good ways of working so that your stuff will look like everyone else's stuff and everyone can compare when they're working on different projects. So the driving principles, and this comes from version 1. First one is, we are not concentrating on writing a framework. We are concentrating on writing libraries first. If we ever do a framework, and we ended up doing one, but if we ever do one, it's going to be built out of the libraries that we will collect together afterwards. We're not building it with a framework in mind first. We're building them as independent libraries. No use of globals within any of the packages. This even goes so far as to say we're not going to use super globals inside our packages. So if you need access to $_server, or get, or post, or any other super globals, your library classes do not use them directly. You pass them in via dependency, well, technically via dependency injection, but it's just passing it as a constructor parameter. Does that make sense to everybody, what we'd be doing there? That way, you're never messing with the super globals and affecting anybody else's business. You're only working on your copies of it. Like we said, no dependencies on any other package. What all of this leads us to is that the tests and the assets that go along with that package are encapsulated within the package. There's none of this, you don't need to run Composer install to run the tests. You download the package, you go to the test directory, you issue PHP unit, and everything is already there for you to run the tests. These are not Git subtree splits where the tests are included someplace else. You don't have to run Composer install to get additional functionality. It's all completely self-contained. The easiest way to enforce all of this is for each library package that you're going to write in a decoupled fashion to have its own repository, either at GitHub or at Bitbucket or whatever it is you like. It needs to have its own repository. The mere fact that you're not going to have access to the files from anything else is going to make it really easy for you to enforce that sort of self-discipline that you're not trying to grab things from someplace else. What you end up with is a package organization that looks something like this. All this up here is, you got your Composer.js and whatever. The important parts are source and tests. These can be named whatever you want. These are sort of semi-standard. Source has all of our classes for a router in this case. Tests has our bootstrap, our PHP and XML, and then the tests for the source code. You download this package. You go to the test directory. You issue PHP unit. These test these, and nothing else. Completely self-contained. If you're writing a package that has web assets, you could include your web assets in here as well. And then whatever installation program you use to glue it together to everything else, would copy those web assets out or link to those web assets in some fashion. Does everyone get this? You see the sort of the decoupled nature even with just this. But the real key, one of the real keys, though, is using dependency injection. Who went to Josh Adell's talk this morning on DAI? Adell's talk, I strongly recommend watching that video when they published it. It's a fantastic introduction to dependency injection. I am going to cover some of the things that he has already covered. When we wrote Solar back in 2004, we used something called service locator, and I will describe this to you later, and something called the universal constructor. Universal constructor meant that every class in the Solar project had a constructor that looked exactly like every other constructor. Had exactly one parameter. That parameter was an associative array. The associative array was key value pairs that got passed in as the parameters for loading up, for configuring that class. Made it very easy to write a single configuration file for the system. So you've got an array in the configuration file for a class. You push that against the class, and it gets loaded up automatically. That was really nice. The problem is, if we're doing separated packages, you can't really use a service locator. And again, we'll talk about this in a minute. If you've got a shared service locator, that means that that's a package dependency, and you can't, we're not doing package dependencies, so you can't use a service locator. What you have to do is something called dependency injection. You don't even necessarily need a dependency injection container. They're just set up so that they will receive their dependencies from the outside. You can use any container you like with any of the Aura library packages. I will assert that aura.di is nice, but you can use the one, you can use the Pimple one, the Zend one, the Symfony Framework one, PHP-DI from Matthew Napoli, whatever you want, you can use it. In addition to all of that, we do not use the new keyword in any of our primary classes. The only time we use the new keyword is in factory objects that we then pass into the objects that need to create other objects. I'll show examples of that later. So this is the kind of thing we're trying to get away from. And everyone has seen this. If you need a database connection in your foo class, this DB equals new database, you do it, right? So this, how can you tell from the outside of this class what dependencies it has? You can't. You have to go examine the code. You have to look through the whole thing. You just can't tell. So one of the, and also, you're also always creating a new connection, right? That kind of sucks for resource usage. So one of the things that people go to very quickly after that is using a registry or something called a service locator. The idea is you have a locator object, or a locator class, that essentially has a registry or an array in it, into which you put single objects that you're going to reuse over and over again. So here we say this DB is, OK, here's my locator class. I want you to go out and get me the DB connection. And then you can set up the DB connection in the locator, and you don't need to change this class at all if your password ever changes. See the point there? What's the problem here? Same problem here. Can't tell from the outside what's going on. Now, this is a lot better than this because, for lots of reasons. You know, we can change the database object without changing this code, but we still can't tell what the dependencies are. There's another way of doing this, and this is to inject the locator, but we still have the same problem. We know we depend on a locator, but we don't know what the locator is going to be asking for. The other version of this is called dependency injection. I'm going to talk about the differences between them in just a minute. Here we say, just pass in, if I need a database connection, pass in the database connection. Constructor from the outside, drop it in. This is constructor injection. This is setter injection. It's the same idea. We just use a method to put it in after we've constructed the object and put our database connection in. Everyone see the difference between those two? The difference is that the service locator is reaching out from the inside to drag in what it needs. Dependency injection, it all gets set up on the outside and then pushed in. So here's the question. How can you really tell the difference here, aside from looking at the code? If you've got a container that advertises itself as a dependency injection container or service locator, if you look at them side by side and they're both named container, they look the same. The implementations of service locator objects and dependency injection container objects are identical. And I had this beaten into me lately because I was trying to say, what's the difference between service locator and dependency injection? You know, I had a whole series of blog posts about this. And when I got to how to tell the difference, and I gave what I thought were my reasons, like other guys was like, oh, there's no difference. And after like 24 hours, I'm like, yeah, I guess you're right. There's really no difference. It's all about how you use them, not about the implementation of them. Any dependency, anything that calls itself a dependency injection container, if you put it into an object so that object can grab its dependencies from the outside, you're using it as a service locator. Vice versa for the service locator. If it's called a service locator and you keep it outside the object, then it's a dependency injection system. Having said that, There are some other ways you can tell if it's intended to be used as a service locator or not. If there are static methods on the container that you're using, like container : get, probably a service locator. The only reason to have a static method is so that you can call it without having to instantiate it from anywhere. If your object implements container aware and then it injects a container of some sort, service locator. If there's a container parameter type hint on a method or in the constructor, probably a service locator, not dependency injection. I've got a series of posts called Quicker, Easier, More Seductive, because service locator in my mind is like the dark side of the force here, because it's quick, it's easy, it's very easy to use, but it leads you into trouble later. Which is why we have this. It is my opinion that dependency injection almost all of the time is far superior to service location. Service location has its benefits, but it really has some drawbacks. It hides the dependencies. If you're injecting a service locator, or even if you're calling it statically, it is also itself a dependency. What we're trying to do is avoid dependencies in this kind of thing. We don't want cross-package dependencies. We want to decouple from as much as we can. In addition to that, it becomes harder, not impossible, not hard in an absolute sense, but harder to write tests for objects using a service locator because you can't tell what the dependencies are. On the other hand, DI is the opposite of this. It reveals the dependencies, especially if you're using factories to push in object creation. You don't have to scan the code to see if it's trying to create new objects. You can tell because a factory is being passed in via dependency injection. It is not itself dependency. Everything gets pushed in from the outside. The dependency container lives on its own. And it becomes a lot easier to write tests, fakes, mocks, that kind of thing, for the objects that use dependency injection principles. Now, having said all of that, service locator is still useful in very limited cases. It is my opinion that if you're going to use service location, it needs to create exactly one type of object. And I don't mean anything your controller happens to need. Let's say you've got a view or a template system that needs helpers. You can use a locator, but that locator should only generate helpers, nothing else. So, and then if you need the service locator, it's trivial to write one, include it in your package. Do not try to grab one in from another package. Does that make sense? Again, these are trivially easy to write. So those are the principles. Any questions on any of that before we get to the examples? So we're going to talk about ORRouter, the second version, the beta version that just got released a couple weeks ago. The description on this, and I want you to pay careful attention here. All it does is it provides a web routing implementation. We give it a path. We give it a copy of $server because it doesn't access it by itself underneath. Extracts the path info, parameters, and some server values for a particular route, and that is all. What is missing from this definition? Calling class, exactly. Does not do dispatching. Does not try to tell you how your controller parameter should look. Does not try to tell you how your action, doesn't even tell you need a controller action parameter. You can use this with DCI setup, an MVC setup, or an MVP setup. God, what are some others? MVVM setups. So this is how you instantiate it. If you're using Composer, you don't need to require the auto load, but it's there if you're not using Composer. There are a lot of people not using Composer. Use the factory, get a factory, use the factory to get the router. This factory does all the complex creation stuff for us. It turns out that in this case, the creation is not that complex. If you want to do it yourself, use these three objects, create a new router with a route collection in it, and in the route collection, we want a route factory. Which of these things creates new objects? I see someone, you raised your head. I can see you, I can see the gears clicking there. The route collection creates new routes. We don't have to look at the route collection code to know that because we pass in this route factory. So adding routes, this is all pretty standard stuff. Add an unnamed route for controller action ID. So any three-part route will match this. Everyone here knows what routers are, right? Anyone here not use routers? I'm not trying to embarrass you because there are some people who don't use them. The idea is that this is going to look at the URL path.
I don't really use them. I know what they are.
You know what they are, okay.
I mean, I've worked with them somewhat in CodeIgniter and that kind of thing.
Yeah, so CodeIgniter, yeah. So the short version is a router looks at the URL path and then extracts information from the URL path so that you don't have to hard code stuff into your file system for paths. So we say /controller action ID, anything with blog, read, 42 would match that. Or we can say we want to add an archive route that matches the URL /archive, optionally with year, month, and day after it. This is the URL, the URI temp. This notation here matches the URI template notation for optional parameters, except these are sequentially optional. You can't have a day without a month. You can't have a month without a year, that kind of thing. This is a more complex setup where we say, blog read ID format, but ID has to be digits only, and format has to be anything with a dot after it, optionally, is the question mark. Regular expressions are your friend in this kind of thing. And the base values here are blog read.html. This is the one I'm proud of. If you want to attach a REST resource, something, if you're doing a real REST API, this one call will add 8 routes for you, all with the proper HTTP methods on them. So attach resource users, named users, to the /users path. We'll create browse, read, edit, update, browse, read, edit, add, delete, create, update, and replace paths for you with the proper names on them, and it will fill in the values for you prefixed with users. So you'll get users.browse, users.read that you can call on later. If you don't like those defaults, you can put in your own resource callable here and then use it to manipulate the router every time you make this call. So again, basic standard stuff. This is where the important part comes in. When we match the route, again, we're not using $server internal to the routing class. We have to pass that information in. So we say the path that we're looking for in our URI is the PHP URL path portion of server request URI. And then we say, OK, give me a route that matches the path that we just set up, and here are the server variables for you to work with. So they're going to look at the HTTP method, maybe some headers, that kind of thing. And it gives you back a route. But I want you to notice here, it's not parsing the URI on it's not parsing the full URI on its own to find the path. You're giving it that information. That means that information can come from anywhere. It doesn't have to come from $server. If you're using engine X and there's a different parameter key or a different array key there, you can work with that array key and just pass that one in. Makes it easy for testing. You don't have to mess with $server in your testing environment. You just pass an array that looks like $server. So that means you can use it in anything. Doesn't depend on a particular framework. Doesn't depend on a request object. Doesn't depend on any particular setup for $server. Questions on this? You see the nature of the decoupling here. We've even decoupled it from the PHP environment. So we get back our route parameters. So let's match blog read 42JSON, get the route params. Gives you back these values, the controller, the action, the ID, and what the format was. And as we noted earlier, this is where the router stops. Doesn't try to create a class for you, doesn't try to dispatch it to anything. That's the part you have to do yourself. Once this is done, doing dispatch is trivially easy any way you want to do it. Now you've got these values, you can manipulate them any way you want. For example, 5 lines of code. Let's get the route parameters. We're going to say the class that we're going to create ourselves is whatever the controller is. We'll tack page on the end of it. So this would be blog page. The method we're going to call in that class is the action parameter with the name action on it. So we're going to call the read action method. Our object is this new class. Echo whatever the results are, calling that method with the remaining parameters. That's it. Dispatch in 5 lines. This is for a full stack framework style where you have your controllers and classes. Another interesting thing here is, because we don't care what these parameters are, this could be in George for all we care, but we're going to call it controller just because we're familiar with it. Instead of the controller being a string, it can be a closure. So we put in our routing system this closure that we're going to invoke later. If this matches, when we get back the parameters, all you have to do is say controller equals whatever that closure is that's in the parameters. Echo it with the rest of the parameters. You're done. Dispatch in 2 lines. Completely dispatch independent. This is decoupling. Does everyone get what we're talking about here? So I said earlier when we wrote the V1 components, some of them ended up being larger than they should have been. That's what I'm going to talk about now. The Aura Web component originally provides tools to build web page controllers and lots of other stuff. Turns out that to use it was a little more complicated. Compare this to the earlier stuff. We need to create our own page class that extends the abstract class from the web package. And then when we instantiate it, we need to create all these new objects to pass into it so it can do all these different things. And all of these things naturally seem like they go together the first time you do them. You obviously need access to the web request environment because you need get, post, that kind of stuff. You need to have a response object because you're sending back a response. You need an accept object to do negotiation between what the client will accept and what you have available. You need a signaling system so that if you're going to do your pre and post exec hooks, that kind of thing, you can signal the rest of the system and hook all that stuff in. You need a renderer, because obviously when you're done setting up your values, you then need to hand off to a template system, right? Does anyone believe these things don't go together? So you end up with a lot of these quote-unquote important parts in the original version. This data to be rendered, a rendering system. In fact, this turns out, so we use something in here called separated interfaces, which I'm not going to, in a previous version of this talk, I talked about separated interfaces a lot. The short version of the separated interface is, if you want to make something pluggable in your decoupled package, you provide an interface in that package, along with an absolute minimal implementation of the interface so that the package works on its own. But then anyone else who wants to override your basic implementation from their glue code will implement your interface on whatever object they've already got that does kind of the same thing. So they extend their object, implement your interface, and then drop it in here, and it works. That's the idea behind a separated interface. That's the most I'm going to talk about it today. But we had this thing called a rendering strategy, where if you wanted to put in your own template system, you could do it. You would just override the rendering strategy. So you wanted to write a naive one where you just include a file with some values in it. You would have to write this kind of thing, and then have your page controller that extended our abstract page controller do this. This is a lot of work. And it all seems like it goes together, right? If you're going to have a page controller, you probably need a base controller. If you're going to be doing action or events of some sort, you need a signaling system. If you're going to be rendering pages, you need a rendering system, blah, 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 blah. But even with the separated interfaces, all those different parts in the package obviously are coupled to each other. But it turns out that there was a lot of repetition between the web package, the front controller system that we had, and the command line system, specifically the dispatching stuff. So the idea, and we talked about dispatching earlier, the idea was that if we could take the behaviors out of one package, take similar behaviors out of two other packages, we could make an entirely independent package that would do the dispatching for us. So in V2 we have something called dispatcher. All it does is contain objects that can be dispatched to. These are your controllers or your commands. And it doesn't care what those controllers are. They can be closures, they can be your own extended base, they can be extended from your own base classes, they can be your own independent objects from your own independent classes. Once we extracted that stuff, it turns out that you don't need a controller, a base controller, in a web package anymore, which means you don't need the signaling system, you don't need the rendering system, you don't need the separated interface, you don't need any of that stuff. It turns out that all that remains is a request and response object for you to put into your own controllers, whether those controllers are closures, your own classes, that kind of thing. So the new description of V2 is provides request and response objects. That's it. But I want to point out these are not HTTP request objects or request objects proper. They're what we're calling web execute or web objects. Anyway, so the Symfony guys, the HTTP Foundation, their request object has like session and environment stuff in it, if I recall correctly. Those are not part of HTTP. So if you've got something that calls itself an HTTP request object and it's got those things in them, it's probably not really an HTTP object. So it's not an HTTP request. All it is a representation of the web execution environments. You get get, post, session environment, and you get read-write on the parameters. You can look at the headers, that kind of thing too. The response object is the same thing. Not an HTTP response. This is a data transfer object. The idea is that it can't send itself. What you do is you take that response object, you translate it through an HTTP delivery mechanism, and then you send it through that mechanism, which means it'll allow you to use any HTTP library at all. We've now completely decoupled our controllers from our request and response objects, and our request and response objects from the HTTP delivery mechanism. Does everyone get that? So what it looks like is this. You write your own full stack controller type. You just inject request and response. You use the request and response to get some post information or tell them that we're expecting to send back application JSON. Or if you're using a micro framework setup where the routing and dispatching logic are all the same, you add a get path to /foo and use you typically use $app, and then put the request and the response in the microcontroller application. And then for sending it, you don't actually need an HTTP library if you don't want to. This is plain PHP code. So we send a header based on the response status line. We loop through the headers in the response status, and we say, OK, send a header with the label and the value. Send the cookies using setCookie. Echo the content and the response. You're done. You don't actually need one when it's all decoupled this way. You don't actually need an HTTP library to send stuff when it's decoupled in this fashion. Now, if you've got one, like guzzle or buzz, you can use that too. You just pull the response headers out of the data transfer object and put them in a buzz, or put them in a guzzle, and send it along. So, there are limits to this kind of thing. The Aura project provides, I think this is 22 different library packages. Each of these is completely decoupled from all of the others. None of them depends on any of the others. The ones that are in bold, and I understand it's probably hard to see on this screen, we have released as V2 beta packages in V2, but they all have V1 versions. So we've talked about the dispatcher, we talked about the dependency injection, kind of. HTML and Vue is another case where we separated packages out. It used to be that all the helpers were in the Vue system, but it turns out you can pull all the helpers out and put a service locator with them, and it works exactly the same way. So you don't need to use the Aura Vue template system if all you want is form helpers. You can use this package. The problem is, at some point, you've got to start combining all this stuff in order for it to be useful. If you've got a front controller, you're probably going to have to combine a router to get the information out of the path, and then that router is going to hand off the dispatcher, which is going to call an object that's probably going to need a request and response object in it, and then you've got to be able to send the response in some way. So you're going to end up combining stuff here. Your action controllers, wherever your controllers are, they're probably going to need a service layer. They're probably going to need the request and response values. If you've got gateway services in the action controller, they're going to need their data source connection, and so on and so on and so on. Which means that we now need to start introducing dependencies at these higher levels, or at these deeper levels, depending on how you think about it. I think of libraries being at the base level and this other stuff being at the higher levels. So when we're doing this, how do we know what ought to depend on what? There's a guy named Robert Martin, who's sort of Uncle Bob. So Robert Martin wrote a book called Clean Code, which I have not read yet, but I've read excerpts of it. He has what he calls the clean code architecture. He says your dependencies, we'll talk about this in a moment, dependencies always track inward and never outward. So at the very core of the clean architecture, we have our core business objects. They have no dependencies on anything but themselves. They don't even depend on a database layer. Around the entities, we have our service layer, or our use cases. They depend only on the entities and on each other. Only outside of that do we have things like our data gateways, our controllers, things like that. And outside of that is where we have the external services, and the database service, the information coming in from the web, that kind of thing. So when you are gluing this stuff together, all the let's say your controller system should not be dependent on a particular database system. Your entities, yeah, right. So your entities should not be dependent on the use cases. The use cases should be dependent on the entities. Dependencies only flow inward and down. And this is really hard to do, by the way. I'm not always successful about this. It's very tempting to have a service layer, or to have your controller system depend on a particular or having your service layer depend on information from the web request. That's the sort of thing you need to decouple. It should be able to deal with web requests, CLI requests, or anything else. So that's the clean architecture. In Aura, the way we separate these dependencies and start gluing stuff together is through what we call kernels and projects. The kernel is a series of files that bind together, for the web kernel in this case, it binds together the dependency injection system, the routing system, the dispatcher, the responder system, and then it adds on some configuration stuff. And that's it. It's really only got about 7 files to it, and the rest is dependencies. And these are the things that bind those libraries together. But notice how very little it does. Anything else that you want, database stuff, that kind of thing, not part of it. You can add it on at the project level. What the project does is it wraps the kernel and gives a skeleton structure to your project. The project is installable by Composer. So you go Composer create project Aura/web-project. It will create that project, grab this dependency, and then this grabs all the lower dependencies underneath it. So again, when we're talking about binding this stuff together and the direction in which our dependencies should flow, we need to be very careful about what we're binding together. The controller should probably be independent of your router and dispatcher. If your controller has to have a particular route object in order for it to work, you're probably busting the clean code architecture. If it has to get dispatched to in a certain way, it knows about the dispatcher, probably busting it. If it's got an external base class, you're probably busting the clean code architecture. And again, service locators here are especially binding if they come from outside the package that you're working with. At the application level, maybe this is OK. But at the mid layers, probably not OK. Which leads me to a final opinion, and that is that micro-frameworks are the antithesis of decoupling. Micro-frameworks are themselves a service locator that have all their services in them. When you put that object, that God object, into your controller, your closure controller, it's got access to all that stuff. You're using it as a service locator, so everything's really tightly bound. It depends on the routing, the dispatching, all the other services that are in that application object. Probably might be dependent on the middleware system too, depending on how it's set up. So, in conclusion, we've talked about sort of the background on where we started at, how people started went to monolithic frameworks and then started trying to develop components. If you're going to develop decoupled library packages, some principles that you should use in order to do that, some examples using Aura, and then finally the limits of decoupling. You know, if we're going to glue stuff together, we need to glue it together in a very specific way. That's all I have. I'm happy to take your questions.
Say you're at a controller, whatever, where it's independent of routers, but the router outputs, like your router output came out with params and these things, they're different. Each router component has a different output. How do you handle, how do you become independent of the different outputs from the independent routers?
So the question is, let's say you've got a routing system, and your controllers depend on different incoming parameters. Is that correct?
Yeah, you try to make your controller independent of the router,
right?
But it expects a specific input. You know,
expects a specific. This is where you
can handle it.
Right. This is where your glue code comes in handy. Notice that the Aura router, all it did was output an array. It did not put a particular object or anything. So there is what testing guys will call a seam between the routing and the dispatching and the controller object. What you would want to do is, between the routing and the dispatching, you want to normalize the output from the router and then hand that off to the dispatcher, which would go off to the controller. So there's a little bit of glue code in that seam where you do the hard work of that's exactly right. That's exactly right. You are in charge of taking from here, making sure it's right, and sending it along to the next thing. That keeps them independent of each other. And it also means that you can pull that router out later if you want, put in another one, make sure that your transition portion is now modifying that correctly, and everything after that stays the same. Yes?
Yes. One of the things that I struggle with is I've got to use examples from my industry.
Sure.
We do airline management software. So
you have my sympathies.
Well, yeah, dealing with technology from the 70s because the big airlines don't want to give that up is a pain. But
still using punch cards.
Yeah. Oh yeah. But we don't deal with them. We only do small airlines that are fine using our SaaS system that uses PHP and that.
Right.
Anyway, so like just basic example, you have like an aircraft object and a seat object. You know, your seat has certain attributes such as, you know, row, seat, zone, stuff like that.
Right.
And so you do have those in separate objects. So obviously your aircraft is going to have a lot of seat objects.
Correct.
So where I'm a little bit, you said that the business classes should be decoupled. I guess I'm a little bit.
Nope. I understand exactly where you're coming from.
Yeah.
Those are your business entities. Those are the things that all bind together, but they don't have particular use cases attached to them. What you're describing are the objects on which everything else operates. So in terms of what you're talking about, an airplane has a seat object, the seat has attributes attached to it. What the airplane object is not going to have is a dependency on a particular database. It's not going to, see what I'm getting at?
Yeah.
So these entities right here can then be wrapped with service objects that use them and make the combination of operations on those entities a lot easier to deal with. So you're not necessarily dealing with the entities directly most of the time. You're dealing with the service objects. Service objects deal with the entities. So that you can say, I need a seat, and then put in some parameters, and then the lower layers, or then that service object then manipulates those objects, those underlying objects, to give you back the proper seat. Does that kind of make sense?
I think so, yeah.
Yeah. So you would feed them in, and you would get them out. But
so
these have.
You would still be storing seat objects in the aircraft object.
You could. It depends on how your. I don't know how your structures are set up.
Right.
This is where. So there's another book called Domain-Driven Development that may be useful to you here. They don't talk about aircraft, but they do talk about transport. and finding the right way to think about whatever the problem is. And just because you're thinking about it a current way doesn't mean it's necessarily the right way to transfer to a good model for a computer system.
Okay.
Does that kind of make sense?
I think so, yeah.
Does that answer your question?
Yeah.
Okay. Other questions?
Technically, we're at time, but there's a break after this. The next session's at 3:30, so feel free to ask more questions. But one last reminder, the break would be a good time to do this. The ticket thing will be gone at the end of the day at 5, so if you want the discount ski tickets, we'll grab those during the break. But
Very good. Before you go, the Aura project is at auraphp.com. If you're interested in these concepts, you just want to see more examples of this kind of thing, go out there. I blog at Paul M. Jones. I'm on Twitter at PMJones. Please rate this talk. We as speakers depend on your feedback, both to improve our own presentations, and the conference people depend on it to see who's good at giving presentations and who isn't. Finally, and this is more of a personal plug, I'm writing a book. It's called Modernizing Legacy Applications PHP. Who is working with a horrible spaghetti mess of code at work? Chris. Yeah, thanks, Chris. Cornat here has gone to a company that I was a startup with, and that poor bastard has the distinction of having to work with code I wrote 10 years ago. Yeah. So mlaphp.com. You'll see linked there a talk that I've given called It Was Like That When I Got Here. It'll give you some initial steps on how to, the talk will give you some initial steps on how to begin improving your code base, but the book is about those initial steps plus about a dozen others on how to improve the quality of the code base that you're in baby steps. Exactly the steps that you need to do in exactly the order you need to do it to make your code base better at work and improve your own life. The publication date is scheduled for March 31, but I'm going to be opening early access to the book next week, maybe the week after that, because I've got to finish the conference here. And you can see the book as it's being written. That is all. Thank you very much for your time.